In this video, we're going to explore how to multiply two binomials. We're going to walk through three different methods, similar to the previous video where I showed how to multiply two-digit numbers. Here, we're going to show how to multiply two-term binomials. And we're going to follow those same three methods. So, method one was our traditional method. And similar to stacking the two-digit numbers vertically, we're going to do the same here. 2x minus 5 and x plus 3. Those binomials are stacked. And instead of lining them up by place value, like the ones place, the tens, the hundreds, here we're lining up by like terms, the constants, the linear terms, if there was a quadratic term or a cubic term, etc., that would continue. So we multiply in the same way. 3 times negative 5, negative 15. 3 times 2x is going to be a positive 6x. Now, we put a 0 as a placeholder in the ones place value before. Here, as long as we keep the columns by like terms, the placeholder does not necessarily matter. But you'll see x times negative 5 is negative 5x. So if I put that in the linear term column, x to the first power, we're good. There is no constant. So sure, you could put a placeholder of plus 0. That would be helpful, but not entirely necessary as long as you're organizing the columns by like terms. Now, we've multiplied x times negative 5. We're going to multiply x by 2x as well, and that gives us 2x squared. So I'll need to create a new column for the x squared terms or quadratic terms. Now, just like before with traditional multiplication of multi-digit numbers, we're going to add these little products. I say little products because it's the product of just two terms in this problem, not the final product of the entire problem. So when we add or combine like terms here that are lined up in columns already for us, negative 15, positive x, and 2x squared. So the final answer here, using the traditional method, would be 2x squared plus x minus 15. Method 2 was the area method, and here that works just the same. We're going to set up our rectangle, and we have 2x minus 5 and x plus 3 are the terms that we're going to use as the dimensions of the larger rectangle. Now when we take and find the small areas, 2x times x, 2x squared. X times negative 5x. 2x times 3 is 6x, and negative 5 times 3 is negative 15. You'll notice the little products are the same that we had up here because, again, we're multiplying the same numbers. We're just organizing it a little differently. Speaking of organization, it's now time to add. Where in method 1, like terms were in similar columns, here the like terms will often be found diagonally. So when we combine like terms, our final answer, 2x squared plus x minus 15, this product is the same as the product in method 1, as it should be. Method 3 uses the extended distributive property just as we did when multiplying two-digit numbers, as you saw before. So here, I'm going to separate the first binomial and distribute the 2x to the second, x plus 3, and the negative 5 I'm going to distribute to the x plus 3 as well. And I call this the extended distributive property because I'm not just distributing one term to a polynomial, rather two terms, or multiple terms for that matter, to the polynomial, so that everything in the first is multiplied by everything in the second. So 2x times x, 2x squared, 2x times 3 is positive 6x. Now the negative 5 times x is negative 5x, and the negative 5 times 3 is negative 15. You'll notice again, these little products, as I've been calling them, are the same as they were in each of the other problems, but organized again a little different. Here the polynomial is written in a line. You may choose to organize this addition problem now for combining like terms similar to the traditional method, even though the multiplication step was set up differently. That's your choice, but when it's just two binomials, this is usually okay, and you'll see the like terms are found in the middle. That's often the case. So as I combine them, 2x squared plus x minus 15 is, again, the same product that we have gotten each time, regardless of the method. Hopefully, this video and combined with the first video on multiplying two-digit numbers 3 ways, now that we've seen this multiplying binomials in 3 different ways, hopefully you see the connection from multiplying numbers in the way that you remember from your educational career so far to now multiplying polynomials in the same methods. In the next video, we'll explore polynomials that have more than 2 terms. So instead of 2 binomials, we might have a trinomial times a binomial. So taking these steps of multiplication and going a little bit further.